Okay, so for today, the first thing we want to discuss is this idea of the remainder theorem. And what that says here is that if I've got a polynomial and I divide by x minus c, then whatever my remainder is f of c. And remember, when we divide by x minus c, we can use the synthetic quick version. So what we're going to do here is I want to find f of 2, so what I need to do is divide by x minus c. C is 2, so we're going to divide by x minus 2. We'll divide f of x by that, and if we get a remainder, it will be the same thing as if we plug 2 into f of x. So we'll demonstrate that. So if we're going to divide, so x cubed minus 4x squared plus 5x plus 3, we're going to divide by x minus 2. So for synthetic division, we put the 2 here, and then the coefficients 1, negative 4, 5, and 3. And our remainder is going to go here, so that will be f of 2. Okay, so let's get started here. 2 times 1, add those, we get negative 2, we get negative 4 here, 1 here, and a 2 here. So when I add this last column, I get 5. So by the remainder theorem, f of 2 equals 5. Let's just go back to the old-fashioned way of calculating f of x. So I'm just going to take f of 2. And we'll verify that, yes, we get a 5 out of that. So f of 2 would be 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. Okay, so that's going to be 8 minus 16 plus 10 plus 3. Okay, so we got negative 8 plus 10 is going to be 2, and 2 plus 3 is 5. Yep, so this checks out. So that's kind of neat. I can just take f of 2 this way, and it goes very quick. Find f of, this time we'll do f of negative 2. So we're dividing by x minus negative 2. So that's x plus 2. So c is actually going to be negative 2 now, right? So we put our negative 2 out here. So it's a little faster here because when you take f of the value, that's the value that goes out here. If you're looking at x minus c, you have to have it in x minus c form so that c comes out here, right? So negative 2. And then our coefficients are 3, negative 4, negative 5, and 4. So constant, so the remainder goes right here. And we're going to get negative 6, negative 10, that'll be positive 20, so 15 here, negative 30 here. So negative 26, this shows us that f of negative 2 is equal to negative 26. Again, let's just plug in negative 2 and make sure that, okay, if I cube negative 2, I get negative 8, so that's 3 times negative 8. Minus 4 times negative 2 squared is positive 4. And then plus 5 times 2 are 10, plus 4. Okay, so we're going to get negative 24 minus 16 plus 14. Okay, so that's negative 24 minus 2, which is negative 26. Okay, so apparently this works. Okay, now we're going to look at how the remainder theorem can be used to solve an equation. So let's look at this one. This is a polynomial, and we want the solution when it equals 0. So remember that f of c is equal to the remainder if we divide x minus c. Okay, so if we want to show that 4 is a solution, let's take x minus 4 and divide it, and that'll give us, if we call this f of x, that would be f of 4. And if we get 0 for a remainder, then that's f of 4 equals 0. So let's take out here and let's take f of 4 if we use this as f of x, and if we get a 0 right here, we know that it's a solution to this. Okay, so doing the synthetic division, and then the 4 times the negative 25 will be negative 100. So when I add these up, indeed I get a 0. So that means that x minus 4 times, and here's the digits for the coefficients of the quotient. So if I take quotient times the divisor, so that would be 3x squared plus 10x minus 25. Okay, so we've got 1 0 and x equals 4. And if we can factor the rest of this, we can find all of the solutions. So let's take our x minus 4 factor out. And then let's factor this top one. And so we need a 5. So let's put the 5 over here. 5 here, we get 15, that'll work out. Okay, so if we just sign this up the right way, we'll get 3x squared and we'll have a 15x. And we want that to be positive. And then this way we get the negative 25 and we take 5 away from 15 and we solve this equation entirely. So we get the x equals 4, but we also get an x equals, if we solve this for 0, set it to 0 and solve, we would get 5 over 3. And then of course here x is negative 5. Okay, so using the remainder theorem, we were able to take one solution that they gave us and whittle this down into an x minus 4, x minus c, times whatever remains, and then we were able to factor what remained, and we've got all 3 of our solutions, and they're all rational solutions. Okay, what we just looked at was really an application of the factor theorem, so we're going to use it and do it again real quickly. So what we've just used the power of this, because if f of c equals 0, then we know the remainder, if we divide it by x minus c, is 0, because f of c always equals the remainder from the remainder theorem. And now if I get a 0 as a remainder, then that means x minus c divides into f of x evenly, and it's a factor. And then likewise, if x minus c is a factor, then of course f of c is going to be 0. So we're going to get a little clue from them again. They're going to say that 3 is a 0 of this function, f of x. So that means that x minus c, or in this case x minus 3, is a factor. Okay, what we don't know is what's the quotient when I divide by this factor, but we know how to find that quickly with synthetic division. We put the c over here, and then here's our digits again. Remember to pad with zeros if you're missing any degrees from the highest degree on down. Constant 6, okay, so this should be a 0 if they're not lying to us. So that's 6, that's 3, that's 9, negative 2, and we can see it coming. So I take that 6 minus 6, and in fact I get a 0. So we're going to take the x minus 3 times the quotient, 2x squared plus 3x minus 2. Okay, so this is another way of looking at f of x up here that they've given us, with the x minus 3 factored out, and that whittles that rest of f of x down to 2x squared plus 3x minus 2. And so let's factor this. And we'll probably want to put a 2 here to get 4. And then minus 1 here to get a negative 2 here, and then the outer plus the inner makes the 3x, and we already had the x minus 3 factored over here. So we've got that third degree polynomial fully factored. And if I wanted to know the zeros of f of x, then I know that x equals 3 is a 0, x equals 1/2, and x equals negative 2. Okay, this next idea, called the rational zero theorem, tells us that the only possible rational solutions, or zeros, so if this is an equation, we would just say 0 equals negative 2x cubed plus 4x squared minus 2x plus 8. So zeros of f of x are the same as solutions to the equation if we just replace f of x with 0. In both cases, the only possible rational solutions are going to be factors of a naught, which is the constant, divided by factors of a sub n, which is the lead coefficient. Okay, so that's all we need to know from our function. So in this case, that's the 8 and the 2. Now we have to consider both cases plus and minus, so we won't worry about signs because we're going to give everyone both a positive and a negative sign. So in this specific case of this example, I've got factors of 8 over factors of 2. Constant, lead coefficient, and then we're going to just look at positive and negative cases for each. Okay, so let's put my factors of 8 up here. Okay, 1 fits into every number. 2 is the next number that fits into 8, and 4 after that, and then every number fits into itself as well. And then down here, we've just got 1 and 2. So we'll just go through and create these rational values that come from combining each of these possible terms. So if I put the 1 over the 1, I get plus and minus 1. If I put the 1 over the 2, I get plus and minus 1/2. Okay, so we've taken care of 1 on top. If I put the 2 over the 1, I've added a new one, plus and minus 2. And if I put the 2 over the 2, that's the same as the 1, so we won't add that again. So now we're done with 2's. If I put the 4 over the 1, then the 4 over the 2 would just be another 2, which we've got. And if I add the 8 over the 1, and then the 8 over the 2 would just be the 4 again. So this is going to exhaust the possibilities. Okay, so the only possible zeros of f of x, or solutions to 0 equals f of x, are going to be a plus minus 1, plus minus 1/2, plus minus 2, plus minus 4, plus minus 8. So there's 10 possible solutions here, and we know how to check them with our, so if I put a c here, and if I get a 0 for a remainder, then I can check each of these out using this synthetic division process, and whichever ones I get a 0 as a remainder, we know that is going to represent a factor, x minus c. So if c garners a 0, we know x minus c is a factor. Okay, now here we're going to use what we just discussed to find some rational 0 of f of x and then whittle it down and find the rest of them. So for instance, the possible rational zeros or solutions to 0 equals this. Same thing. So are going to be plus minus factors of 6 over factors of 4. Okay, so that's going to be plus minus 1, 2, 3, 6. And down here, a plus minus 1, 2, and 4. Okay, so that's going to be plus minus 1, plus minus 1/2, plus minus 1/4, and then 2 over 1, plus minus 2. 2 over 2 is 1, we got it. 2 over 4 is 1/2, and we got it. Adding the 3 over 1, and we'll also add 3 over 2. Over 4. Okay, and then we got 6 over 1. 6 over 2 would be 3, which we've got. 6 over 4 would be 2/3. Yeah, so we need to add 6 over 4. Or 3/2, I'm sorry. Yeah, and we do have 3/2. Alright, never mind that. Okay, that's a lot to try, but we're going to just try with the easy ones first. So we'll start with the positive 1. List our digits out here. See, we go from 3 to 2, so that's good. 19 and 6, so we got something for every slot. So that's negative 15. And we'll do a positive 4, and that's not going to work, so let's move on to a negative 1. That's way too big, so scrap 1 and negative 1. I'm going to pass on and just try the integers instead of the... If we have to get back to those, we can. So let's start with the 2. And there it is. Okay, so we know that x minus c, which is x minus 2, and then 4x squared minus 11x minus 3 is another way to factor f of x. So we know one of the zeros of f of x is x equals 2. Now the question is, can we factor this? If we can factor it, it's a little easier. So let's take a 4x here and an x here, because I got to build a negative 11. And then let's put 3 here and 1 here. So that x minus 3 will give us a negative 12x, but if I take plus 1x, that gives us the negative 11 in the middle. So yes, it does factor. And not only is x minus 2 a factor, so is 4x plus 1 and x minus 3. Now notice negative 1/4 is in our list, so that would have worked here. X equals negative 1/4. And then 3 is in our list, and that would have worked as well from this 0. Okay, so we were able to whittle it down with the use of this rational zeros, and then either factor, or even if when we get it down to a quadratic, we could also use the quadratic formula, or we can keep using these if we want. Okay, really not introducing anything new here. Now we're just going to use that same tool that we used to find the zeros of f of x to find the solutions to an equation. So if we had just called this f of x, and we're asked to find the zeros, we would do it the exact same way that we're going to do this, because the zeros of f of x are zeros to this equation as well. All right, so we got plus minus factors of 4. All right, we get that from the constant, and then plus minus factors. Ooh, nice. Okay, so the lead coefficient this time is just a 1, so that makes life easy here. All right, so that's going to come out with a plus minus 1, plus minus 2, and plus minus 4. So pretty limited set of possibilities to start things off here. And I always just like to start with 1. Okay, and make sure we've got padding if necessary. So if I didn't have the 8x squared here, I would need to put a 0 in x squared's place, but I do, so negative 8. Next one's 14, and then negative 4 over here. So obviously we want a positive 4 here, so we get 0. So bringing this down, negative 7, it's not 7, and then this would be 7. So 1 is not going to do it for us. Let's move on to a negative 1. It's not going to do it either. Let's move on to our 2's. So with the positive 2, there it is. Okay, that means x minus 2 is a factor, and we can rewrite the equation as x minus 2 times x squared minus 6x plus 2 equals 0. All right, so we've got a solution here. Let's see if this will factor for us. I don't think it will. No, look at that. We need a negative 6 in the middle. You know what that means? That means we have to use the quadratic formula, and then a is equal to 1, right? B is equal to negative 6, C is equal to 2. So to get the rest of our solutions to this, we're going to say x is equal to negative b, so that's going to be negative 6, otherwise known as 6. And then in here we're going to get b squared, so negative 6 squared is 36 minus 4 times a times c, and all that goes over to a, so 2 times 1. Okay, so that means x is equal to 6 plus and minus the square root of 36 minus 8. We can bring a 4 out. So 7 times 4 being 28 is going to change this to 6 plus and minus square root of 4, which is 2, times the square root of 7 over 2, and then divide everybody by 2, and we'll get 3 plus and minus the square root of 7. All right, so our solutions we only have one rational solution, and that's x equals 2 from that factor. And then from the quadratic formula, we have two irrational solutions. So 2 along with 3 plus and minus the square root of 7. Okay, so I'm going to go put something on my lab here for y'all, and have a great break. We'll see you when we all get back.